Now we are going to solve this problem. This problem was asked in GATE 2007 of 2 marks. So it states that 100 kVA 415 volt line to line, a star connected synchronous machine generates rated open circuit voltage of 415 volt at a field current of 15 ampere. The short circuit armature current at a field current of 10 ampere is equal to the rated armature current. The per unit saturated synchronous reactance is. So synchronous reactance has been asked, that is this problem falls under synchronous impedance of synchronous machine. So first we will draw the two characteristics required for evaluating ZS. So one is VOC and another one is ISC against IF. So one gives open circuit characteristic under open circuit test against VOC and IF. So suppose this is the OCC, you may mark OCC, and this is our SCC, short circuit characteristic against ISC, between ISC and IF. So this is 100 kVA capacity of the synchronous machine is given as 100 kVA, line to line voltage. So if we want rated VPH, rated, you may mark rated. So this will be line upon, this is a star connected, right? So for a star connected, we know the relation between line voltage and phase voltage. So this will be this upon √3, fine. Generates rated open circuit voltage of this, that is line voltage, at a field current of 15 ampere. So whatever rated voltage is there, that is obtained, let us take this as rated one. So this is obtained at a field current of, mark it, IF1 is equal to how much? 15 ampere. So write it as 15 ampere, fine. And this is VPH rated, VPH rated, this one, fine. Next, the short circuit armature current at a field current of 10 ampere, obviously 10 ampere is lesser than this. So some other field current, let us take this as 15. So okay, 10 will be something, this is 0. So okay, let us take here. So IF2, and this is how much? The short circuit armature current at a field current of 10 ampere, this is 10 ampere, IF2 is 10 ampere, and corresponding short circuit armature current will be this one. The short circuit armature current at a field current of 10 ampere is equal to the rated armature current. So this is IA rated, IA rated, fine. The per unit saturated synchronous reactance is. So as told earlier, out of the 4 quantities, if 3 are given, then 4th one can be easily evaluated, fine. Or rated IA rated may further be evaluated with the help of these ratings given. We know that IA rated may be written as capacity 100 kVA upon root 3 into line voltage, that is 415 volt. So whatever it is coming out to be, we know IA rated. We have to evaluate synchronous reactance, saturated synchronous reactance, not unsaturated, right? Saturated. So for performance analysis, generally we used to evaluate at rated value, which is normally near to saturation. So we will take the ratio of open circuit voltage upon short circuit current at the same value of field current. So for that we need to evaluate this short circuit current. Corresponding to IF1. Remember, earlier in previous lecture we discussed that synchronous impedance is nothing but ratio of open circuit voltage to the short circuit current at same value of field current. So we need to evaluate this. Let us mark it ISC1. So take the two ratios. Let us take tan theta. So that will give you ISC1 upon IF1, that is ISC1 upon IF1. ISC1 is not known. We are going to evaluate with the help of other three known currents, right? So what are other three known currents? We have taken tan theta, this upon this, that is ISC1 upon IF1. So in this triangle, tan theta will give you this, that is IA rated upon IF2. This will be IA rated upon IF2. This implies ISC1 upon IF1 is 15 is equal to IA rated. How much it is coming out to be? Just calculate this. So IA rated is coming out to be 100 into 10 to the power 3 upon root 3 into 415, 139.12. So this is coming out to be 139.12 ampere. So substitute it, IA rated as 139.12 upon what is IF2? 10 ampere. So this way we can evaluate ISC1 as, so ISC1 will be this upon this into 15. So ISC1 is coming out to be 208.68. 208.68 ampere. Just check it yourself. Now once ISC1 is evaluated, now therefore synchronous impedance saturated, you may mark saturated, may be evaluated as open circuit voltage, which is per phase 415 by root 3, 415 upon root 3 upon ISC1 at same field current. ISC1 we have evaluated 208.68. So this is coming out to be 1.148 ohm. 1.148 ohm. So nowhere RA has been given, it means RA has been ignored. So the per unit, okay, this has been asked in per unit, not in actual. Okay, if it will be asked in actual synchronous reactance, that will be the answer, but it has been asked per unit, so we need to convert it into per unit. So for that we need to evaluate Z base, and per unit value will be actual upon Z base. So what is Z base? We know that knowing capacity S base and kV base, we may evaluate Z base as, Z base may be written as kV base square upon MVA base. Fine. For a star connection, right? For delta, we know that 3 comes here, right? That has already been explained in per unit lecture, per unit system. So KV base is this is 415 volt. It means KV base will be equal to 0.415 square KV base. What is MVA base? This is 100 kVA. So MVA means 0.1 MVA, right? 1000 kVA is 1 MVA. So in MVA base will be 0.1. So this is coming out to be 1.72225. 1.72225. Z base is coming out to be this. Hence, the per unit value of ZS in per unit will be equal to actual, that is 1.148 upon base value 1.7222. Take up to certain decimal, 2 decimal places is enough, right? So this is coming out to be 0.66657. 0.66657 in per unit. And as stated earlier that if RA has not been mentioned, then by default it is ignored. So the same will be the value of per unit saturated synchronous reactance. So the nearest value out of the 4 options is this C, hence C is the correct answer. Fine. This problem was asked in GATE 2014 set 1. This is also on synchronous impedance. It states that a star connected 400 volt 50 Hz 4 pole synchronous machine gave the following open circuit and short circuit test results. So the two test results are given as open circuit test. Under open circuit test, VOC is 400 volt. It's given line to line. Even though if it is not given, then we know that by default the given voltage will be line to line. Fine. At field current of 2.3 ampere, and under short circuit test, the short circuit current 10 ampere RMS phase, whether phase or line, it is star connected, it will be same. Even though not given, we can understand it. At field current of this, the value of per phase synchronous impedance in ohm. Sometimes actual value might be asked, sometimes per unit value might be asked. So synchronous impedance in ohm at rated voltage is. So from given data, we know that VOC 400 volt, which is the rating of this machine. This is a star connected, hence rated VPH will be 400 upon root 3 per phase, right? And under open circuit test, we will consider this VOC and IF. So this is obtained at field current of 2.3 ampere. That is, this is obtained at field current IF1 is equal to 2.3 ampere. Fine. Under short circuit test, ISC of 10 ampere is obtained at field current of 1.5 ampere. So let us take this is 10 ampere short circuit current, which is obtained at IF2 is equal to how much? 1.5 ampere. Fine. Now we need to evaluate synchronous impedance, that is ZS, at rated voltage. So it means we know that this is nothing but open circuit voltage upon short circuit current, that is ISC1. So from here we may write VPH rated upon corresponding at same field current. The short circuit current is represented by ISC1 here in this plot at IF, which gives rated voltage under open circuit test, that is 2.3 ampere. From definition we may write the ZS asked at rated voltage like this. So we know the value of VPH, that is 400 upon root 3 upon ISC1. We don't know, we need to evaluate it. Again the same technique as discussed earlier. So how to get that? Take two similar triangles. So in one tan theta will be ISC1, we may write here ISC1 perpendicular upon IF1, and in this triangle, right angle triangle, the same tan theta may be written as, this is perpendicular is 10 ampere, 10 upon perpendicular upon base is IF2. So substitute the values. This implies ISC1 upon IF1 here is 2.3 is equal to 10 upon IF2 is 1.5. This implies ISC1 is coming out to be 15.333. 15.333 ampere, right? Now substitute this value of ISC1 here. So we will write 15.333. So this is at, we may write at IF is equal to 2.3 ampere. So this is coming out to be 15.06. Check yourself in ohm. Fine. So this way we can solve problems asked on synchronous impedance. Fine. Thank you very much. Try some other problems yourself, whether asked in GATE, IAS or any other exam. Try to implement the concepts learned in these two lectures. Thank you very much.